I'm here with Amida Torrigiani, and hi Amida.
Hi.
I have a question. Why are you here?
Today we are here in this wonderful event. Okay, thanks to our partners, our German partners, and we are here with a group of students that are delegates from our European project that they are trying to involve the public in some chemical and physical experiment.
Okay, what are you doing here?
We are here because we're from Italy to show in this context our experiment that we have tried in our classroom with the CNR, an Italy association that is provided about the research international, and
we're here. Our experiment is to recover the phosphorus, that is of course a raw material, from urine that is everyday life, and we can check it in public bathroom or school. And phosphorus is going to finish, and we have to try a way. We have to try to find a way to recover it, saving energy, and that we can use it in everyday life. In fact, the results of our experiment is a fertilizer, very rich, of course, in phosphorus, that everyone can use at home.
That is a baker with the mashed soybeans, that with the adding urine. That this is urine, synthetic urine in this case. We have the possibility to react the urease content in the soybeans with the urine to turn the pH of the solution from acid to basic.
Yes, because the pH of urine at the beginning, just of urine, is completely acid, as you can see, and at the final step, after a few minutes of mixing, the pH of this solution, of course mashed beans and urine, is completely basic, and this green is the color that we need to make struvite able to precipitate. And of course with adding of magnesium sulfate that accelerate the process, of course we have these results, because after we filtrate the solution and we add the magnesium, the struvite becoming to precipitate.
Okay. So this is how it works. We are here to show you how magnets works basically, and magnetism.
Okay, and could you explain your experiment to me?
Yeah, our experiment is very basic, but it tells you everything we are doing here. And for example, there are two magnets, and they repel each other very strongly, and they are made of a raw material, which is neodymium, while the other ones are very weak, and they are made of ferrite. And our aim is to make people understand that we need to use them very properly, because we import them from China and other countries, and they are very important materials for our energy and motors or other things. And this is basically what we are doing here. But we are also doing some basic experiments about magnetism, and we want to teach people basic things.
What's the main message you want to tell the audience?
Okay, first of all, the first message is that science is also fun, okay? It's not annoying, but is very important. Okay, so you can have fun and learn. And second, also the student can help us to disseminate some very good content among the public, so they can act like the first actors, okay? In fact, we call them young ambassador, science ambassador, okay?
The fact is, we come from Italy, and in Italy we have a lot of dairy sheep which produce milk and cheese, which is obvious, it's excellent. But we also produce a lot of wool, which we can't use because it's very coarse and hard wool. It's not soft. We can't make jumpers or T-shirts, so we have to find an alternative way to use this wool. And CNR has developed this method which utilizes wool to filter streams or waters, rivers that may be near a factory or an industry. So since these waters will be rich in copper or heavy metals in general, what we're thinking of doing is using this wool, and in special using the properties of keratin to absorb these heavy metals such as copper. So in these experiments we're showing how wool can extract the keratin from this liquid, and finally later we show how triggering a redox reaction with aluminium and copper, we can get this copper to attach itself on the aluminium foil. So in this way we can filter the water and block the copper, and then we can utilize this copper again after this reaction, and in this way we can recover the copper and use it to make I don't know, coins or whatever. So it's a win-win situation, let's say, for wool and for copper.
Could you explain your experiment to me?
Yes. The first one is a chromatic division, because inside each color there are different colors, such as the black is a compound of colors such as blue, yellow, green, and so on. Another experiment is a magic bottle. Inside this bottle we put some hydroxide of sodium, some glucose, and blue methylene, that is a colorant. And if you shake the bottle, it will become blue. But the bottle is not shaken. It's like water, it's transparent. And you can do it wherever you want, anytime, for 6 hours. It's very curious. Another one is the chameleon, the rainbow. And in this experiment we use permanganate of potassium, and it's used to change it. It changes color if you use sacharosium. In fact, as we put sacharosium and hydroxide of sodium, the color will change from violet to green, then yellow and brown.
Thank you for the very great welcome, and thanks to Clausthal University and also to Raw Material Academy because they support us, and thanks to all.